In this video we have to learn about the magnetism. Is the chapter 2 of unit 3. Now in magnetism we will learn, as we know, magnetic field B is represented by B. Its unit is Tesla. It's a vector quantity. Now magnetism is what? It's a magnetic field acquired by the body in presence of an magnetic field. There are some few definitions for magnetism. Like first definition is these are some important terms related to chapter magnetism. First of all, magnetizing field means magnetizing field is that exists in vacuum induced magnetism is called magnetizing field. Magnetic field setup in solenoid is this. The name suggests it is as magnetizing field, as according to the name magnetizing field. Magnetizing field means, suppose a field is applied here, a material is placed in presence of this field. Now this field induce magnetism in this, induce magnetic properties or magnetism in this material. So this field is now named as magnetizing field. Second definition is magnetic induction. Under the influence of magnetic field, movement of atomic current loop of a magnetic material tends to ally themselves with or against magnetic field. It means, like inside every atom there are atoms, and atom have some magnetic movement. In presence of an external field, as we know, magnetic movement is what? IA. In presence of an external field, this magnetic movement tends to lie themselves in a particular direction. This is called magnetic induction. Next is magnetizing field intensity. The ability of magnetizing field to magnetize a magnetic material, that is called magnetizing field intensity. Suppose if field B naught is there, how much it can magnetize the material, that's the intensity of this field. More it can magnetize the material, more is the intensity. Less it magnetizes the material, less is the intensity. So this is represented by H, where H is equals to Ni, or we can also write B in the term of mu naught H, where mu naught is permeability. Next term is intensity of magnetization. It is measured as the magnetic dipole moment developed per unit volume. It means what? The material is there in presence of a magnetic field. This material get magnetized. How much it get magnetized, that is called magnetizing of this material. How much it get magnetized. So this is called intensity of magnetization, means how much a material get magnetized in presence of an external magnetic field. Magnetic field intensity means how much a magnetic field can magnetize a material. Intensity of magnetism, how much a material can get magnetized in presence of magnetic field. So it is defined as magnetic moment per unit volume. So here we know M is equals to nothing but N into IMA, where because IA get cancelled with A, so B is equals to mu naught IM, or instead of IM, if we have a number of terms here, so it get mu naught M. Next term is, so total magnetic field is mu naught H plus mu naught M, magnetized field or field. Magnetic permeability is the Permeability is what? How much a medium can allow magnetic field lines to pass through it is called magnetic permeability. It's given by mu by h. Relative permeability, if we compare permeability of two medium, say of free space, for free space is represented by mu naught and of a medium is mu. So if we compare this both, we get mu r is equals to mu upon mu naught. So this is relative permeability. Next is magnetic susceptibility. How much a magnetic material can suscept external electric field, that is called magnetic susceptibility. And magnetic susceptibility is denoted by a symbol chi m. This is called chi. This is how much intensity of magnetization upon magnetic field intensity. So relation between mu and chi m, if we have to find that relation, as we know B is equals to mu naught h plus m. Substitute the value of B, that is mu h. So mu, taking h common here, we get m by h here, h with h cancel, so we get this thing here. So this is the relation between permeability and susceptibility. Now there are three type of material: diamagnetic material, paramagnetic material, and ferromagnetic material. Diamagnetic material means which are repelled by magnetic field, B. Paramagnetic material which are weakly attracted by magnetic field. Ferromagnetic material which are strongly attracted by a magnetic field. So diamagnetic material first of all. Substances are those which get weakly magnetized in direction opposite to the direction of magnetizing field. These substances move from stronger to weaker because they are repelled by the magnetic field. As diamagnetic material are repelled by the magnetic field, so they will move from stronger to weaker field. Or para and ferro, as they are attracted by the magnetic field, so they will move from weaker to stronger. Now next is this is representing dipole moment. First of all, as we know, electron revolve around the positive in this direction. Current is in opposite direction to the flow of electron, so it has dipole moment which is in this direction. This is the direction of dipole moment. But if the current is in this direction, dipole moment is in upward direction. So net moment is equals to m plus delta m minus m minus delta m, and this will give us 2 delta m. From here and here, by solving these two equations, we get 2 delta m. Why so? Here, if we apply magnetic field in this direction, this get magnetic field this, and if magnetic field is applied in this direction, for as magnetic dipole moment in upward direction, so we get m plus delta m, and when we solve this, we get 2 delta m is the net magnetic dipole moment. Next is paramagnetic material are those material which magnetize weakly in direction of B, such that they move from weaker to stronger field. It is due to presence of some unpaired electrons due to which non-cancellation of spins on, and due to this region they will acquire some magnetism. Para means which have unpaired electron in them which are randomly oriented. This domain is randomly oriented, and when field is applied on this magnetic field, they start oriented in particular direction, due to which their magnetic moment start raising the value, and as a result their magnetism increases. So intensity of magnetization is directly proportional to H, as M is directly proportional to H, or M is directly proportional to this. So combining these two effects, we get M equals to C by H, or M by H is equals to Ct, where MH is equals to chi m. So from whom chi m is inversely proportional to T temperature. So this is the graph for this para. Next, ferro. In ferro, there are not only one unpaired electron, there are number of unpaired electrons which are randomly oriented, and they have particular domains in this system. They have not only single unpaired electron, but they have domains like this. So when external magnetic field is applied, they started orienting in the direction, and this time they get strongly magnetized. This material gets so strongly magnetized. For diamagnetic, para and ferromagnetic, value of chi-m is negative for di, positive but less value for para, positive but very high value for ferro. Where we know that relation between permeability and chi-m is, this is the relation.